Today we are going to discuss about principle and applications of colorimeter. So, colorimeter, it is an instrument which purely concerned with the visible region of spectrum, and it is used for the measurement of intensity of color of a given color solution. Then this instrument normally works on the basic principle, that is amount of light absorbed by the given solution. So that's why this instrument is called as absorption meter. So principle, when a monochromatic light is incident on homogeneous medium, a part of light is reflected and a part is absorbed by the medium. The absorption of light by any absorbing material is governed by two laws. So first one Lambert's law and the second one BS law. So Lambert's law, the amount of light is absorbed is directly proportional to the thickness of the absorbing material, but it is independent of the intensity of the incident light. The formula is I by I naught is equal to E minus KB. I is equal to intensity of the transmitted light and I naught is equal to intensity of the incident light. B is equal to absorbing thickness and K is equal to absorption coefficient. And the second one, BS law. So this law states that the amount of light absorbed is directly proportional to the number of absorbing molecules. So Lambert's law, BS law get together to form Beer-Lambert's law. So Beer-Lambert's law means this law states that the amount of light absorbed is directly proportional to the concentration of the absorbing material and the number of absorbing molecules. Next one is Beer-Lambert's law. So Beer's law, Lambert's law combined together from Beer-Lambert's law. The absorbing material is directly proportional to the thickness of the material and the absorbing molecules. So the combined equation is then written as log 10 I naught by I is equal to ABC. Here K and K dash merge to become a single constant A, and B is equal to absorbing thickness or path length, and C is equal to concentration of the absorbing material. Then if the optical density of the known standard solution is known, for example, we have to know about the unknown solution optical density, then we have to follow the particular formula. Concentration of the unknown is equal to OD of unknown by OD of standard into concentration of standard. So this is the principle of colorimeter. Then instrumentation. So the basic instrumentation in a colorimeter includes the following. First one is sources of light. So light source is the major important task in the colorimeter. In this, tungsten filament lamp is the most commonly used source for the visible radiation. So in ancient days, tungsten filament lamp is highly used. Then it continuously emits radiation in the region between 350 and 2500 nanometers. Next one is the wavelength selector. So all the sources described above emit continuous radiation over wide range of wavelength, but a loss of absorption is applied only to the monochromatic radiation. Here wavelength selectors are mainly two types. First one is the filters and the second one is the monochromators. Filters operate by absorbing light in all other regions except one for which they reflect. Example, gelatin filters. And a monochromator resolves polychromatic radiation into its individual wavelength and isolates these wavelengths into narrow bands. The components of a monochromator are entrance slit, which admits polychromatic light from a source, and a collimating device which collimates the polychromatic light onto the dispersion device, dispersing element which breaks the radiation into component wavelength. Next, fourth one, focusing lens. And fifth one, an exit slit, which allows the monochromatic beam to escape. The entire assembly is mounted in an airtight box. For example, here, this is the instrumentation of the monochromator. Source light and entrance slit, collimating device, focusing lens, and sample holes. And two kinds of dispersing elements are widely used. First one is prism and the second one is gratings. Here sample cuvettes are also used. Samples to be studied in visible region are solutions. And the solutions are disbanded in cells known as cuvettes. The cuvettes used in visible region are made up of ordinary glass or quartz. Next, applications of colorimeter. So this colorimeter is mainly used for the qualitative analysis. Example, visible spectrophotometer used to identify classes of compound from both pure state and biological samples. This is usually done by plotting absorption spectrum curves. Example, chlorophyll 660 nanometers and 420 nanometers. And colorimeter is useful for the quantitative determination of a particular compound in the biological sample or any unknown sample solution. And the third application is it is used for the assay of enzyme activity is carried out most quickly and conveniently when the substrate or the product is colored and absorbs light in the visible region. This instrument is mainly based on the visible region of spectrum. So visible region means if we have to give a colored solution, then we can identify the intensity of the particular solution which is given. So what is the principle? So principle is mainly two. One is the Lambert's law and second one is the BS law. Here only single light is available, that is monochromatic light. This monochromatic light is passed throughout the solution. Then this light is absorbed by the specific solution at specific wavelength. So based on this principle, they find out the two principles, Lambert's law and BS law. So Lambert's law means the amount of light absorption is directly proportional to the absorbing material, thickness of the absorbing material. And BS law, the amount of light absorption is directly proportional to the absorbing molecules, amount of absorbing molecules. Formula is I by N is equal to E minus Kb. By using colorimetry, we can identify the concentration of unknown sample. By using this formula, that is OD of unknown by OD of standard into concentration of standard. So then the instrumentation contains different parts. First one is sources of light. So mainly we use the tungsten filament lamp is the most commonly used source for the visible radiation. It emits radiation at 350 to 2500 nanometers. Next, wavelength selector. All the sources described above emit continuous radiations, but wavelength selectors are mainly two types. First one is filters and the monochromators. So filters are mainly operated by the absorption of light. Example, gelatin filters. And the second one is monochromator. So monochromator means polychromatic radiation is resolved and it can form two narrow bands. So this monochromator, the component of monochromator are it contains entrance slit and collimating device and dispersing element. This is the diagrammatic representation of monochromator which contain entrance slit, source and prism, etc. And we use sample cuvettes for the sample loading. And these cuvettes are made up of ordinary glass or quartz. Finally, applications of the colorimetry. So this calorimetry is useful for the quantitative determination of a particular compound in the biological sample or any unknown sample solution. It is also used for the assay of enzyme activity in the specific solution or in the colored solution. Then this is also used to identify the classes of compound from both pure state and biological sample. Example, chlorophyll 660 nanometers and 420 nanometers.